There's a picture of me and my Bearcat card. For question 1, A is equal to the set containing 1 and 2. Decide if each statement is true or false. So to define the power set, it is the set of all subsets, including itself and the empty set. So the power set of A would be the set containing the empty set, the set containing 1, the set containing 2, and the set containing 1 and 2. So for A, is A in the power set of A? You can clearly see that the set containing 1 and 2 is inside of the power set, so that would mean that A is true. For B, is A a subset of the power set of A? So for A to be a subset of the power set of A, the individual elements 1 and 2 would have to be inside the power set of A. We have the set containing 1 and the set containing 2, but the individual elements are not inside the power set, so that would make B false. For question 2, come up with an example of open sentences P and Q with the property that for all of x and z, P of x implies Q of x is false, and there exists x in z such that P of x implies Q of x is true. So an implication is a logical construction that tells us if the premise, then the conclusion. The universal quantifier is true for the entire domain, while the existential, it can be true for only some of the domain. So for P of x, let's do x is in z, the integers. And for Q of x, we can do x is in n, the natural numbers. So when we have the universal quantifier for all of x and z, obviously P of x will be true, since it gives us that for all of x and z, any x that you pick will be inside z. And then when you do, for Q of x, x is in n, this will not be true for any x that you pick. If you pick, let's say x is -1, that's an integer, but it's not a natural number. So if you pick, so for every x, that will not be true, giving you a false Q of x. So then when you have P of x is true implies Q of x is false, this will give you a false implication. So for the existential quantifier, there exists x in z. Obviously, again, P of x will be true. So it's true if it's universal, and then it's also true if it's existential. If you pick, let's say, x is 1, then x will be inside of z. For Q of x, where x is in the natural numbers, this is also true. It doesn't need to be for the whole domain of the integers. It can be any x. So if you pick x is equal to 1 or 2 or 3, that's a natural number, so that will give you a true Q. So when P of x is true implies Q of x is also true, that will give you a true implication. For question 3, use the sentence, at the restroom, she ordered fries or chips to illustrate the different interpretations of or. In English, or is an exclusive or. And then in math, or is used as a standard mathematical or. Exclusive or, so this will actually be false if both fries and chips are true. You can only have either fries as true and chips as false, or fries as false and chips as true. And that gives you 2 different possible options, where fries is true and chips is false, or fries is false and chips is true. In math, you can have both fries and chips being true. It doesn't need to be one or the other, and then the rest of it will stay the same. This gives you 3 different options where fries and chips can both be true. Fries can be true and then chips will be false, or fries is false and chips is true. Thank you.